All right, Chapter 6 Review, Polynomials Test Part 2. Let's get after it. So number 1, looks like we have a box with some dimensions. Write a polynomial equation to represent the volume of the box. All right, so remember, volume is just length times width times height. And let's call this the length, that's the width, this and the height. So let's write that out. So volume is length times width times height. And we can go ahead and we can multiply that out. And so I'm just going to kind of do these last two. I like to do the last two and then distribute the x plus 3. So that's going to be x squared minus 2x. Or actually, take that back. That's the difference of squares. So that's just going to be x squared minus 1 for that back part. And then I have an x plus 3. So this is just a normal. So x times x squared is x to the third. That would be plus 3x squared minus 1x minus 3. And then they tell you, so this is the volume function. Well, then right below they tell us that the volume of the box is 105. So I'm going to scroll down and rewrite that. So that's plus 3x squared minus x minus 3. Maybe I can get it right in the right spot. Let's see. Nope, I'll have to move it up here a little bit. But nevertheless, I still have my answer there. But this time they tell me that the volume is 105. So I can replace v with 105. And we had x to the third plus 3x squared minus x minus 3. And we want to solve that because we want to figure out what x is. So I'm going to set it equal to 0. And I'm going to minus that 105. So at this stage, what I could do is I could do the P over Q, find all the possibilities, but I'm going to graph on this one. I'm going to try to speed it up a little bit. And I'm going to try to graph this. Kind of knowing just ahead of time that the factors, I could do, 1 and 108, 2 and 54, 3 goes in there, 36, 4 goes in there, 27, 5 doesn't go in there, 6 goes in there, 6 goes in there, it's at 18, 7 no, 8 no, 9 goes in there, 9 goes in there 12 times, and I believe that's it. So those are all my possible roots if it's rational. So I'm kind of looking for 1, 2, 3, 4, 6, something like that. But we'll see. So let's graph this thing. So pull up the old graphing calculator, slide it over, turn it on, and let me go in here and clear this out. And let me get my, so x third positive 3x squared minus x. Just kind of sketch this out on the board so I have it. That way I don't screw up a negative sign. All right, so we have x to the third plus 3x squared. Oh, talk on it. X to the third, arrow over, plus 3x squared minus 1x minus 108. And let's just graph it, see what's going on. And I'm going to change my window. I'm going to go back to standard. So zoom, standard. See if the regular window gives me anything nice. So it looks like I see something crossing at 4. And maybe I'll change. Let's go to my window and let's make my x's bigger. Let's go all the way out from, I don't know, maybe go from 0 to 50, let's say. Go by 5s. All right, so I only saw the 1 right there, so I believe that was at 4. Let me just check the table. Second table. And of course my table set's all weird. So table set, start at 0. Let's just go by 1s. Go back to the table. Yeah, so it looks like I have a 0 at 4. So let's give that a shot. So if I go back up to my problem at the top and I plug 4 in, let's see what we get. So 4 minus 1 would be 3. 4 plus 1 is 5. 4 plus 3 is 7. And 7 times 5 times 3, that's 105. Boom. So I do know that x equals 4. So, although it didn't ask for x at one of the dimensions. So 3, 5, and 7 would be the dimensions for number 1. All right, moving right down. Number 2. Simplest polynomial function was 0, so we're going to work backwards. We have zeros. Let's get some factors. If I have a 0 of 4i, that means that I also have to include negative 4i. So I'm going to have x minus 4i, x plus 4i, and then an x minus 2, and an x plus 2. All right, well, difference of squares here. So that's x squared minus 16i squared. But remember, I squared is just negative 1. So I'm going to have that when I replace negative 1 for I squared. And then over here, I'm going to have a difference of squares, x squared minus 4. So now we can kind of clean this up a little bit. That would be x to the 4th minus 4x squared plus 16. So that's a plus 12x squared. And then we have minus 64. So there is a simple polynomial function that will have the zeros that they called out. So you just got to work backwards. Get your factors, go backwards. Number 3, sketch the graph of a polynomial that has a degree of 4 and a negative leading coefficient. So what I'm thinking here is something like, I don't know, y equals negative 2x to the 4th plus, who cares, because none of this matters. So a quick little sketch of that means x to the 4th means they're going to go in the same direction. And the negative means it's going to come down. So it's going to go something like this. You know, that would be some sort of x to the 4th. So the end behavior is as x approaches infinity, or heads in this direction, y is going down to negative infinity. And as x moves in the negative infinity direction, it looks like y is also going down. So there would be the end behavior for that particular function. Number 4, what is the multiplicity? So just remember that's a vocab word. Multiplicity means the number of times that something is a factor. And so we're trying to figure out the root negative 1, how many times that shows up here. I could graph that. That would definitely be a way. And remember, what I'm looking for is, if negative 1 is a root, that means that as it crosses negative 1, you know, if there's some possibilities. One is if it just kind of comes up through here and just kind of goes up, that's going to only happen one time. If somehow it comes, or actually x to the 4th is going to be coming down. But if it comes down and it bounces, then that means it could happen, it could either be a 2 or a 4 multiplicity. So I'd have a couple options there. Or if it bends, you know, if it comes down and it kind of bends right there, then we know that it's got an odd multiplicity, like 3. So, I don't know, we could graph it, but I'm just going to try to do some algebra. Let's just see what happens with this. So when I do the PQ stuff, P over Q, Q is just plus or minus 1. 4 is plus or minus 1, 2, and 4. So this wouldn't be too bad to try on a table. So let's just try. So 1, -2, -3, 4, 4. And we're going to run a little table here. See what happens. Probably could have graphed it just to make it, just get my start quicker, but I'm this far. Let's keep going. 1 times 1 is 1. Added, I get -1. -1 added, I get -4. 1 times -4 added, I get 0. 1 times 0 added. So 1's not a factor. So can't use 1. So let's try -1. Slide it down. -1 times -1 is -1. Added to 2 is -3. -1 times -3 is 3. Added to -3 is 0. -1 times 0 is 0. Added to 4. And -1 times 4 is -4. Added to 4. Boom. So I've locked down one of these. So right now I know I have x equals -1 once. So let's use this right here to kind of keep going. All right. So I'm going to use that, 1, -3, 0, 4. And let's just see if -1 does it again, if it goes in there again. So bring it down, multiply, add, multiply, add, multiply, add. So there's another one. So there's another -1. All right. Well, we have something we can try again. So let's try this one right here and see if -1 works again. It worked once, it worked twice. Who knows? Maybe it'll work 3 times. See what shakes out. Slide the 1 down. -1 times 1 is -1. Add together, I get -5. -1 times -5 is 5. Add them together, get 9. So it doesn't work there. So I believe that it's going to have multiplicity of 2. I think there's 4 zeros. And it looks like it worked twice. So let's look at the graph and let's see if we see a bounce at -1. So pull up the old graphing calculator. Slide it out of the way. Turn it on. Y equals. And let's just clear that out. X to the 4th. Arrow over. Minus 2x. 3rd, move it over, -3x squared, move it over, plus 4x, and plus 4. Probably could have just started graphing right away. Let's go enter. Let's do a zoom standard, just go back to our normal window, see what shakes out. Ooh. Yeah, so it looks to me like we have a double root kind of right here. Looks like we have a double root at x equals -1. Looks like it happens twice. And it looks like we have another double root at x equals 2 because it bounces there. So I believe this one, the correct answer, it's confirmed, is B. So you can graph it, you can synthetic it. Kind of showed you both ways. Your call. Number 5, what is the degree of the simplest polynomial with integer coefficients that has those guys as zeros? So I have an irrational, so I know those come in pairs. I have a rational, so that they don't come in pairs. Then I have a complex, which those also come in conjugate pairs. So it looks like this is going to be a degree 5, because I have 1, 2, 3, 4, 5 zeros there. So basically you just had to know that irrationals and complexes come in conjugate pairs. So there's really 2 of them. Number 6, find the local max and min for that function. Let's graph it. You know, I know just by the end behavior that I'm expecting it to do something where it comes down, goes up, comes down, goes up. So at most, I'm looking at 2 mins and a max. So that's kind of what I'm thinking is going to happen, but we don't really know until we graph it. So let's pull it up. Move him out of the way. Y equals. I can use the x to the 4. Let's just clear it out. It's probably faster than monkeying with it. X to the 4th minus 4x to the 3rd plus 3x. So we're missing an x squared term. Just notice that. And plus 5. And let's graph it. All right, so it looks like my x's, I could tighten up my x's, and you know, just kind of looking at this, I might go from, looks like all the action is happening maybe between like -3 and 1, 2, 3, 4, I don't know, maybe 6. So I'm going to make my x's go from -3 to 6, but my y's got to go deeper. Like I see a max here, I see a min there, but I need to go deeper. So my y's, I'm going to go down in the negative a little bit. So let's change our window, -3 to 6 on the x. So window, -3 to 6 on the x's. And let's make this like -20 to 10. Maybe we'll go by 2's. And let's see what we can do here. What happened to my y's? Oh, I changed the 2 in the wrong spot. I want to go up to 10 still. But then I want to go by 2's. Beautiful. So now I'm going to calculate in 3 different places. So let's go to second trace, which is the calculate function. Let's find that first max. And actually, let's find the, well, I'll get the max since I'm already in the max mode. The maximum is going to be at this top. So left side, enter. Right side, enter. Guess. Boom. So we have a max at 0.55. So we have a max at x is 0.55. We have a height, a y value of 6.08. All right, so there's that maximum. Let's go back and let's get the minimum. So let's go second calc min. And let's back it on up and find this little valley over here. Go to the left side of the valley, hit enter. Go to the right side, hit enter. Guess. So we have a minimum at -4.7 when I round it. So min at -0.47. And the y value there is at 4.05 rounding. I didn't really tell you what to round, so nearest tenth would be fine. I'm just going to the 100th to make it a little bit more pretty. Well, then we have another min. So second calc, another min. And we got to go way down here at the bottom of this valley. So enter on the left side of the valley. Enter on the right side. Guess. And there is our final minimum, local minimum. And the x value is 2.91. And the max is -13.13. So those are our 3 local highs, local lows for that particular function. So make sure you know how to use your graphing calculator to do that kind of stuff. All right. Number 7. A box is constructed. So we've kind of done a few of these before. We did it in quadratics, now we're doing polynomials. Let's check it out. So we have sheet metal, 20 by 16. We're cutting out x's. So when I folded up my volume, and it says does not have to be in standard form, so I'm going to save you some time here. So the volume is the length, which is this area, which is going to be 20 minus 2x, because you're cutting out two squares. And then we're going to have a width of 16 minus 2x. And then don't forget there's going to be a height of x when you fold that thing up. So what is the maximum volume? So remember, our y value is the volume. Our x is how big the square cut should be. So when I use my calculator to do the max here, we're wanting to know the x and the y, and we need to know what they represent. So let's kind of pull up the old graphing calculator, put them to work again. Go to y equals, clear that out, and we had 20 minus 2x, parenthesis, another parenthesis. This just saves you from having to multiply it all out. That's why I said, hey, it doesn't have to be in standard form. Thought we could speed up this process a little bit. And then times by x. And the graph, I really don't know what's going to happen. I know like 16 times 20 is 320, but it could go higher. So let's just go to our window. We can't cut out a piece bigger than 8, because if we cut out a piece bigger than 8, then our 16 side disappears. So I'm going to go from 0 to 8. So that really limits the x's. The y's can't be negative or we won't have a box. And I don't know, man. Let's go big. Let's go like 500 by 50s. And it might be way too big, but let's just kind of see. Ooh, man, I got lucky. That was beautiful. All right. So those are the possibilities. So let's calculate that maximum. So second, trace, max. And I got to go to the left side first. Left side of the mountain, enter. Right side of the mountain, enter. Guess. Max at 2.94. So it looks like the max volume is going to be this y number. So our maximum volume is approximately 420.11 cubic feet. That would be my units. And how big should the square cuts be? About approximately 2.94 inches. So that will maximize the volume of that box. All right. And number 8. I like number 8. It's kind of a little puzzle. I could see this as an SAT type question. But if there was a remainder of 3, when you divide this dividend by this divisor, I finally got those two straight, so kind of feeling big, bragging about my vocabulary. But when I divide the thing in the rectangle by the thing underlined, I know I have a remainder of 3. So that means when I do synthetic division, if I use 3 as my divisor, so I'm going to put 3 in there, and I'm going to do 1, 4, negative h, and 30. All right. Well, I already know the answer is going to give me a remainder of 3. So this clue, the remainder, that's what we're at right there. So I kind of know how it ends. And I know how it begins. It goes 3 times 1 is 3. Or bring the 1 down. 3 times 1 is 3. Add them up, I get 7. 3 times 7 is 21. And then when I add those two numbers up, well, right now I'm kind of stuck, but wait a minute. I can kind of think over here. 30 plus what will give me a 3? I think that needs to be a negative 27. All right. So somehow I did 3 times this number to get negative 27 there. So this must have been a negative 9. Well, now I can kind of hone in on, I know what happened right there. I know that negative h, when added to 21, gave me a negative 9. So when I solve this, and I subtract 21 from both sides, I get negative h equals negative 30, multiply or divide by a negative 1, it looks like that h must have been 30. And apparently, I changed these answers because these were from the wrong problem. But it should have been one of the choices. So I actually kept this up from earlier in the day. So let me just so we'll remember the answer was 30. So let me get rid of that and let me open this back up and find Google Drive, Honors Advanced Algebra, Chapter 6, Review Part 2, because I know I redid this and I resaved it. So let's just make sure it matches up with what we changed our answers to. And it doesn't look like it did. Correct answer is 30. If you're watching this, I probably printed these before I changed the answers. But the correct answer is definitely 30. All right, hopefully that helps you out and you can get yourself ready for the test. See you.